Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Badke. In today's video lesson, we will perform an activity to find an expression for the area of a trapezium. This will be activity number 4 in your journal. Aim of this activity is to find an expression for the area of trapezium using the method of paper cutting and pasting. To do this activity, you must know that a trapezium is a quadrilateral with one pair of opposite sides as parallel. You must also be familiar with the properties of parallelogram. A parallelogram is a quadrilateral in which both pair of opposite sides are parallel and equal. Following material will be required to do this activity: marble paper of 2 different colors, a pair of scissors, glue and geometry box. The procedure to conduct this activity is very simple. The first step is to cut 4 identical trapeziums from 2 different colored marble papers. This means that 2 trapeziums will have same color. The second step is to paste 2 trapezium of different colors as design, and then we will label them. The third step is to align the remaining 2 trapeziums such that the resulting figure is a quadrilateral. This quadrilateral is to be pasted under conduct. So let's start with the activity. On a marble paper, draw a trapezium, that is a 4-sided figure such that one pair of opposite sides is parallel. So here in this trapezium ABCD, I have drawn AB parallel to DC. Now obtain an identical cutout of this trapezium on another colored marble paper. Label the second trapezium as PQRS. Now obtain a replica of trapezium ABCD and of trapezium PQRS. So now we have 4 identical cutouts of this trapezium with the color combination as shown in the figure. You can choose any 2 colors that you want. Out of these 4 cutouts, we are going to paste 2 cutouts as design. So on the plain side of the journal, give the heading as design and paste these 2 cutouts as shown over here and label them as trapezium ABCD and PQRS. Now mark the midpoint of AB as E and the midpoint of PQ as T. Using your protractor, draw a line EF. Such that EF is perpendicular to AB. Repeat the same steps on other trapezium. That is, at point T, draw a perpendicular that cuts SR at X. So what we have done is, we have drawn the perpendicular distance FE between the 2 parallel lines AB and CD. Similarly, on the other trapezium, XT is the perpendicular distance between the parallel lines SR and PQ. Mark this perpendicular distance between the parallel lines as H. Since both figures are identical, we can mark the distance between PQ and SR also as H. Now we will label the two parallel sides as A and B. So let AB be equal to A. So PQ will also be of length A. And label the side DC as B. So SR will also be labeled as B. Now this design is complete. Now according to the third step, we have to do the conduct. So to do the conduct, we are going to use the remaining two trapeziums. Now these two trapeziums are to be aligned to form one quadrilateral. But before aligning them, write down the vertices of these two trapeziums at the corners of the figure as I have shown. So what we can do is flip one trapezium and then align it with the other one so as to get a quadrilateral as shown. Now label the quadrilateral so obtained. The blue quadrilateral is ABCD and the orange quadrilateral was labeled as PQRS. And the perpendicular distance between the parallel sides is marked as EF in the blue trapezium, and in the orange trapezium it was marked as TX. Let's mark the sides of this quadrilateral. We have marked QP as A. And DC is marked as B. So the length of QC will be A plus B. Similarly, we have marked RS as B and AB is marked as A. So the length of RB will be A plus B. Also QP is parallel to RS and DS is parallel to AB. So we can conclude that in this quadrilateral QC is parallel to RB and QC is equal to RB as both these sides are A plus B. So we have shown in this quadrilateral RBCQ. One pair of opposite sides is parallel and equal. And we have studied theorem 8.8 which says that a quadrilateral in which one pair of opposite sides is parallel and equal is a parallelogram. So this implies RBCQ is a parallelogram. And we have already established that area of a parallelogram is base into height. Now the base of this parallelogram is RB and the corresponding height is marked as H in the figure. Substituting RB as A plus B, area of this parallelogram is equal to A plus B times H. Now this parallelogram is made using two trapezium. So we can write area of parallelogram is equal to 2 times area of one trapezium ABCD. Therefore, area of each trapezium will be equal to half times A plus B into H, where A and B are the lengths of parallel sides of the trapezium and H is the perpendicular distance between these two parallel sides. So whatever we have observed and written over here is to be written under observation and conclusion. Under observation, we will write that two trapezium add up to form a parallelogram whose base is RB, which is sum of two parallel sides of the trapezium AB and SR. RB is sum of AB and SR, that is A plus B. Since this parallelogram is obtained by combining two trapeziums, area of each trapezium will be half area of parallelogram, and area of parallelogram is base into height. So area of each trapezium will be half base into height. The base of parallelogram is RB, which is sum of the two parallel sides A plus B. So the area of trapezium is half A plus B times H. So we can conclude that the area of trapezium is half the product of height and the sum of its parallel sides. With this, we come to the end of this video lesson. Your assignment for today is to complete this activity in your journal neatly. See you in the next class. Until then, goodbye.